My dear students, in this video, I am going to derive some equations of a line in space. In the previous video, we have derived the direction cosines and direction ratios of a line and how to find the direction cosines and direction ratios of a line. In this video, I am going to introduce equations of line in space. The first equation is equation of a line passing through a point and parallel to a given vector. Vector equation of a line. Vector equation of a line passing through a point and parallel to a vector, parallel to a given vector. Vector equation of a line, vector equation of a line passing through a point and parallel to a given vector. For that, you consider the space coordinate axis OX, OY and OZ are the three mutually perpendicular coordinate axes, and IJK are the unit vectors acting along the axis OX, OY and OZ respectively. IJ and K are the unit vectors acting along OX, OY and OZ respectively. Now I am going to find out the equation. This is an equation of a line. We have to determine this equation line passing through the point A and parallel to the vector B. We have to find out the equation of this line which is passing through the point A and parallel to the vector B. Okay. For that, to join OA. Okay. So P is any point on the line this is a point P on the line, any point on the line. OA is vector A and OP is vector R. O is the origin. We have to find out the equation of this line AP which is passing through the point A, given point A and parallel to the vector B. OP is vector R and OA is vector A. A is any point on the line. OX, OY are the coordinate axes. Since vector AP and vector B are parallel, AP is any given point. A is any given point, passing point line. A is any given point through which the line is passed. A is any given point through which the line is passing. A is any given point whose position vector is A vector. That is OA vector is A vector. And OP, P is any point on the line. P is any point on the line. A is any given point through which the line passing. P is any point on the line whose position vector OP vector is equal to R vector. Since AP and B vector are parallel, since B vector and AP vector are parallel, the condition of parallelism, AP vector is equal to some scalar time of the B vector. Since AP and B vector are parallel, the vector AP is some scalar time of B vector, that is lambda times of B vector. So AP is lambda times of B vector. So from the triangle OAP, from the triangle OAP, OP vector equal to OA vector plus AP vector by triangle law. OP vector equal to OA vector plus AP vector. OP vector is our vector given, and OA vector is A vector, and AP vector is lambda times B vector. So lambda is any scalar. Lambda is a real number or it's a scalar. Okay. So vector equation of line passing through the point A and parallel to the vector B is R equal to A plus lambda B. This is the required equation of the line. Vector equation of the line is this: R equal to A plus lambda B, where lambda is any scalar. Since AP and B are parallel, AP vector is some scalar times of B vector, because that is the condition for parallelism of two vectors. Therefore, AP vector equal to some lambda times of B vector. Therefore, by triangle law, OP vector equal to OA plus AP. OA is A, AP is lambda B. Therefore, by triangle law, OP vector R vector equal to A plus lambda B. That's all about the book part. A plus lambda B. So R vector equal to A plus lambda B is the vector equation of a line passing through the point and parallel to the vector given vector B. That's all. Now the same for this same line, Cartesian equation. How to find out the Cartesian equation of this line? Now Cartesian equation of this line. So this is the vector equation. Now Cartesian equation of a line passing through the point and parallel to a given vector. In this case, the line passing point A is given by the vector A. Now vector A vector is given by x1i plus y1j plus z1k. So this is x1 y1j plus z1k, because the point A is given by x1, y1, z1. Similarly, the point P is x, y, z. The point P is x, y, z. Point A is x1, y1, z1. Therefore, A vector is x1i plus y1j plus z1k. And OP vector R vector is xi plus yj plus zk. This is your OA vector is A vector and OP vector is R vector. And B vector, any parallel vector B, parallel vector B is given by AI plus BJ plus CK. So therefore, the parallel vector is given by AI plus BJ plus CK. Therefore, the Cartesian equation of this required line is R equal to A plus lambda B is the vector equation. In this equation, you have to substitute. Vector equation is R equal to A plus lambda B. R equal to A plus lambda B. But R is xi plus yj plus zk equal to R vector is xi plus yj plus zk, which is equal to A vector is x1i plus y1j plus z1k plus lambda times of B vector is plus lambda times of B vector is ai plus bj plus ck. Now, after rewriting this vector equation, r equal to a plus lambda b is the vector equation. For r vector, we will substitute for r vector xi plus yi plus zk, for a vector x1 plus y1 plus z1k, and plus lambda times of b vector. B vector is a plus b plus zk. Now you bring this x minus x1 into I, common I, take x minus x1 to I, plus y minus y1 into j. You bring this x1 y1 z1 to the left hand side, plus z minus z1 into k equal to lambda times of ai plus bj plus ck. Okay. Now comparing the I, j, k coefficients on both sides. Comparing the coefficients of I vector, j vector, k vector on both sides. For eliminating lambda, x minus x1 equal to lambda a. Therefore, from this I can get x minus x1 by a equal to lambda. X minus x1 by a equal to lambda. Similarly, comparing j coefficient, y minus y1 equal to lambda b. From this you get y minus y1 by b equal to lambda. Similarly, z minus z1, coefficient of k is z minus z1 equal to lambda times of c. From this you get z minus z1 by c equal to lambda. So, comparing all these three, all are expressions for lambda, therefore I get the Cartesian equation is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c, which is equal to lambda. You need not write, it is the same constant. So Cartesian equation is x minus x1 by a plus y minus equal to y minus y1 by b equal to z minus z1 by c, which is the Cartesian equation of the required line. Vector equation is r equal to a plus lambda b is the vector equation. Cartesian equation is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c, which is the Cartesian equation of the required line. Okay. Let's talk about the vector and Cartesian equation of a line passing through a given point and parallel to a given vector. Okay, using this idea, I am going to solve one problem. Find the vector and Cartesian equation of the line passing through the point 5, 2, minus 4 and parallel to a vector given 3a plus 2j plus minus 8. You will see. Problem is, find the vector and Cartesian. Find the vector and the Cartesian equation of a line. Problem is, find the vector and Cartesian equation of a line passing through a point. The point is passing through a point 5, 2, minus 4. Passing through a point 5, 2, minus 4 and parallel to a vector parallel vector is 3i plus 2j minus 8k. This is our problem. Passing point A vector. Here point A is 5i plus 2j minus 4k. If just substitute the point 5i, A point, Y vector is A, the point A. A is 5, 2 minus 4, therefore 5i plus 2j minus 4k is the passing line passing the point is 5i plus 2j minus 4k. and OP vector is general point R vector xi plus yj plus zk, and parallel vector B given as, what is that, 3i vector plus 2j vector minus 8k vector. So vector equation R equal to a plus lambda b. R is xi plus yj plus zk left hand side. Right hand side is substituting for this R vector is same vector xi plus yj plus zk equal to a vector. A vector is 5i plus 2j minus 4k. R vector equal to a plus lambda times of b vector is 3i vector plus 2j vector minus 8k vector. So R vector equal to a plus lambda b. This is the vector equation. Just substituting for R, a and b. Now Cartesian equation x minus x1, x minus 5. This is x minus 5 into I, y minus 2. y1 is x minus x1 is 5, y1 is 2. So y minus 2. Z minus z1, z1 is minus 4. So minus of minus 4. Z1 is minus 4. So minus of minus 4. Into k equal to lambda times of b vector is 3i plus 2j minus 8k. This is x minus x1. So from this you can rewrite that x minus x1 by a. A is 3, b is 2, c is minus 8. That's all. So in this equation you can substitute x minus 5 by a, 3, equal to y minus 2 by 2 equal to z minus of minus plus 4 by minus 8. C is minus 8. X minus x1 by a, y minus y1 by b, z minus of minus plus 4 by c is minus 8. So a 3, b 2, c minus 8. So this is the Cartesian equation of the line. X minus x1, x minus y by 3, y minus 2 by 2. Because this is x1, y1, z1 is 5, 2 minus 4. This is x, y, z. A, B, C are 3, 2 minus 8. This is our ABC. B vector is 3, 2 minus 8. So x minus x1, x minus x1, x minus y by 3, y minus 2 by b is 2, z minus of minus plus 4 by c is minus 8. That's all about that vector and Cartesian equation. This is the vector equation and this is the Cartesian. That's all about the problem. Okay? Next, I am going to find out the vector and Cartesian equation of the line passing through two given points. Our next idea is vector and Cartesian equation of a line passing through two given points. Vector and a Cartesian equation of a line passing through two given points. Vector and Cartesian equation of a line passing through two given points. Not a parallel vector. Here there are 2 points are given. Vector and a Cartesian equation of a line passing through two given points. One point A. Two given points. One point A is x1, y1, z1, and other point B is x2, y2, z2. So we have to find out the vector and Cartesian equation for the line passing through A, x1 is written, and this is your B, x2, y2 is a. So now we have to find out the line passing through two given points x a x1 is written, b x2 y2 is a 2. We have to find out this vector and Cartesian equation. The line passing through the two given points. In this line, you can consider a point P as x, y, z. It is any point P on the line AB, and its position vector is R. This is the diagram for this problem. This OP vector is R vector and OA vector is A vector. OB vector is B vector. This is OB vector is B vector. So we have to find out the vector equation of line passing through the two given points A and B. So the line here, the given line passing through the 2 points A and B. Point A is x1 minus z1, point B is x2 y2 is z2. The position vector of the point OA is A vector, which is given by x1i plus y1j plus z1k, and the point B, position vector of the point B, OB vector is x2i plus y2j plus z2k. OB vector is x2i plus y2j plus z2k, and R vector is as equal to xi plus yj plus zk. And R vector is OP vector, which is given as R vector, that is nothing but xi plus yj plus zk. So now vector equation of the line passing through the two given points A and B. In this case, the point P, A, P, B are collinear. The 3 points point A, P and B are collinear. Now, the position vector of AB. Now, for this problem, position vector, the position vector of the line AB, required line AB. AB is the required line passing through the two given points A and B. Is OB minus OA. OB is B vector minus OA is A vector. So AB vector is OB minus OA. OB is B. OA is A, B minus A. Now the vector AB and AP are collinear because the points A, P, B are collinear. Vector AB. Vector AP and AB are collinear vector. Therefore, AP vector is some scalar times of AB vector. Since the two vectors are collinear, one vector AP vector is some scalar time of other vector AB. That is lambda times AB vector is we derived as B minus A. So AP vector is we derived as lambda times of B minus A. So this is AP vector is lambda times of B minus A. So now that in the triangle OAP, from the triangle OAP, from the triangle OAP by triangle law of vector addition, OP vector equal to OA plus AP. You consider small triangle OAP. OP vector equal to OA plus AP. OP vector equal to OA plus AP vector. You know OP vector is R vector. OA vector is A vector plus AP vector is lambda times of B minus A vector. So this is the vector equation that I am passing through two given points. R vector equal to lambda times of B minus A is the vector equation of line passing through the two given points. R vector equal to A plus lambda B is the vector equation of line passing through a single point and parallel to a vector. That is the bookwork we have seen in the first bookwork. Passing through a single point and parallel to a vector is R vector equal to A plus lambda B only. Suppose two given points are given, the required line passing through that two given points is R vector equal to A plus lambda times of B minus A. Now we have to see the Cartesian equation of this line. You will see the Cartesian equation of this line passing through the two given points. Okay. You know Cartesian equation, R vector is, you know that to find Cartesian equation, the Cartesian equation, R vector is xi plus yj plus zk. R vector equal to A vector is x1i plus y1j plus z1k plus lambda times of B minus A. R vector equal to A plus lambda times of B minus A. B x2y plus y2j plus z2k minus A vector is x1a plus y1j plus z1k. Therefore B minus A is x2 minus x1 into I plus y2 minus y1 into j plus, there is no space for here, just R vector equal to A plus lambda times of R vector equal to A plus lambda times of B minus A is x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. R vector equal to A plus lambda times of B minus A. This is your R vector equal to A plus lambda times of B minus A. B minus A is x2 minus x1y plus y2 minus y1j plus z2 minus z1k. Now comparing the coefficients again, you will get the Cartesian equation. In this case, you bring this x1, y1, z1 to the left hand side, I get x minus x1 into I plus y minus y1 into j plus z minus z1 into k. X minus x1 into I plus y minus y1 into j plus z minus z1 into k equal to lambda times of x2 minus x1i plus y2 minus y1j plus z2 minus z1k. Now comparing the coefficients of xi, j, k, x minus x1 equal to lambda times of x2 minus x1. X minus x1, coefficient of I, left hand side is coefficient of I, the right hand side is lambda into x2 minus x1. This is x minus x1 by x2 minus x1 equal to lambda. Similarly, by comparing the coefficient of j, y minus y1 equal to lambda times of y2 minus y1. This is y minus y1 by y2 minus y1 equal to lambda. Similarly, comparing that z minus z1 equal to lambda times of z2 minus z1 k. That is z minus z1 by z2 minus z1 equal to lambda. By comparing all these three, x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1, all are lambda. Therefore, the Cartesian equation line passing through the two given points is, Cartesian equation is right here. Cartesian equation is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. This is the Cartesian equation of the line passing through the 2 point A and B. X minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. This is the Cartesian equation of the line passing through the two given points. Okay? That's all about this book. We will see the problems in the next video. Thank you.